We would like to thank our affinity partners, TD Insurance, Manulife, and First Foundation, whose support makes events like these possible. And I have the pleasure of getting to introduce you to our host and moderator this evening, Dean of the Faculty of Science, Dr. Martina Kalkunas-Rupel. Dr. Kalkunas-Rupel is an internationally recognized scientist whose research centers on the biology of acoustic communication in bats and mice. She is recognized for being a leading thinker in science pedagogy with a commitment to providing authentic and inclusive research experiences in the classroom, laboratory, and field. Her expertise is reflected in her track record in funding and knowledge translation. She has been funded by the National Science Foundation and the National Institutes of Health, as well as other government agencies, non-governmental organizations, and industry for basic and applied aspects of her research. And I'd like to welcome Dr. Kalkunas-Rupel.
Thank you, Katie. Hi, everyone. I'm thrilled to be here to moderate this presentation today. And I really want to get to our presenters. So I'm just going to offer a few items of news from the Faculty of Science. And we're in a pandemic, and I think we are celebrating in many ways because we're coming to the end of our winter semester and coming to the end of a full academic year where we've delivered our programs and continued our research and had students advance through their degrees in a pandemic year. So students are finishing the winter semester. We're gearing up for spring and summer research activities as well as classes. And then we're really working on planning for the fall because students are going to start registering for fall classes next week. And as you might imagine, we are making decisions almost on a daily basis about what the fall will look like. But what we know it will look like is just another fantastic year for students and researchers growing and developing their work and as scientists in the faculty. And you will hear about some of that work today. And I'm so pleased to introduce you to our speakers. Dr. Eleni Stroulia is a professor in the Department of Computing Science and the director of the AI for Society signature area at the University of Alberta. Formerly, she's held Natural Science and Engineering Research Council of Canada and Alberta Innovates Technology Future in Research Chair, Technology Futures Industrial Research Chair on Service Systems Management with IBM. Her research focuses on addressing industry-driven problems, adopting AI and machine learning methods to improve or automate tasks. Dr. Stroulia's flagship project in the area of healthcare is the SmartCondo, in which she investigates the use of technology to support people with chronic conditions to live independently longer and to educate health science students to provide better care for these clients. And we're so delighted that she directs AI for Society at the University of Alberta. Dr. Nidhi Hegde is our other speaker, and Dr. Hegde is an associate professor in the Department of Computing Science at the University of Alberta. She's a fellow at the Alberta Machine Intelligence Institute, or AMI, and holds an artificial intelligence chair from the Canadian Institute for Advanced Research. Hegde's current research goal is to investigate how outcomes from AI and machine learning methods breach privacy and impact fairness and bias. And she's also interested in designing algorithms that are private and fair by design. Before joining the U of A, she was a research team lead at Borealis AI, which is a research institute at the Royal Bank of Canada, where her team worked on privacy preserving methods for machine learning models and other applied problems. I am so delighted to welcome Drs. Stroulia and Hegde to our Science Connects today, and I will pass it over to both of them. Welcome, Dr. Stroulia and Dr. Hegde.
Okay, so thanks so much, Dean Kalkounis-Rupel, for this so very generous introduction. I'm delighted to be here with my colleague Nidhi Hegde, who's working in this area now, and it gave me the opportunity to go back and review research that I was reading as a graduate student not so long ago. And the discussion is very timely. If you are aware, the Stanford Human-Centered AI Institute publishes every year a report called AI Index. The 2021 AI Index was published just this March, and basically it has a few, I believe, 9 points of interest, and 2 of them are directly relevant to our conversation today. So one is a statement or the understanding that surveillance technologies are becoming increasingly fast and cheap, and therefore they're becoming increasingly ubiquitous. So audio surveillance, video surveillance is pervasive in the world we live, and information is collected about us and our activities and our faces without us quite understanding how much it is. Partly because of this uptake of surveillance technologies, we see an increase in the research interest among the scholarly community about ethics. So if you look at the graph, there is a distinct visible uptake in the number of papers that are in technical conferences and journals talking about ethics-related issues. And ethics-related is broadly conceived as everything that has to do about decision-making that is not transparent or explainable, decision-making that may be suffering from bias and discrimination because the data is non-diverse and not representative, as well as privacy intrusion. What we see is that the scholarly community is very interested in actually establishing technical solutions to all these ethics concerns, but we do not quite see an equal interest from organizations that are using AI out there in the world, and we don't quite have yet technical solutions or quantitative tests that would enable us to understand exactly how ethical our systems are. So this is where we are today, and in sort of reaching today, Nidhi and I have decided that we'll go a little bit of an overview and see where we started from, and we organized our presentation in 3 main chapters. First, we'll talk about the early days, where AI was in its infancy and the machines were not particularly powerful, and the concerns were quite abstract and theoretical, philosophical. Then we see a change in the late 1990s, 2000s, where the machines are becoming quite interesting and capable, and now the concerns become quite more realistic and specific. And finally, we reach our days today, where we really see very specific problems that are reaching the news, and we see the need for technical tools to address these problems. So going to the early days, I want to start with the so-called first MESA conference on cybernetics. There are 2 events that are usually referred to when people are talking about the beginning of AI. The first one is the first MESA conference on cybernetics in 1946. So this brought together an interdisciplinary community of scholars around the science of cybernetics. And basically cybernetics is the science that believes or relies in the notion of circular causal chains. As you can see at the top right, entities perceive the world, decide on an action, then perceive the world again, and the difference between what the world was before and what is now is driving subsequent action. So this kind of causal chain or reaction feedback is at the core of many biological and social systems, and was believed by this community to be at the core of our human intelligence. Now, this group back then, when in 1946, included people like Norbert Wiener, who was a mathematician, and Margaret Mead, who was a famous cultural anthropologist and sociologist, and also included a philosopher, a single philosopher participating, Norbert Northrop, who gave a paper that basically argued that ethics can be derivable by a scientific framework, and this is our task. So basically, he argued that we have to develop a valid normative theory grounded in science that would guide how the machines that were going to be built based on cybernetic principles would be ethical. So his talk was not particularly quite well received, and it apparently, as is reported in the proceedings, he didn't participate after his presentation much, and nothing happened out of it. In 1956, a young John McCarthy coined the term artificial intelligence. He was a young mathematics professor in Dartmouth College, and he put together a proposal asking money to support a 2-month, 10-month study of artificial intelligence. And that was apparently the first use of the term. And the idea was, the proposal was that these 10 men for 2 months would be in Dartmouth and would develop a framework that would plan the research forward for every aspect of learning or any other feature of intelligence. So at this time, the statement of what intelligence was is purely cognitive. And the objective is, the methodological assumption is that this intelligence, cognitive capacity, exemplified by humans, can be simulated by a machine. So this is a strong AI position. A machine can be made to be cognitively similar to humans. Now, this group was definitely non-interdisciplinary, and there was no notion of sociology or philosophy. This was a technical conference. It was not particularly successful in the sense that people did not actually stay for 2 months, but this was the beginning of AI. And 50 years later, when there was another meeting of the same group, McCarthy said that he wanted to nail the flag to the mast and start artificial intelligence, because at the time, there was mathematical research that seemed similar, but nobody was talking about intelligence. So that was the beginning. It was not particularly concerned with ethics. But as time progresses, we see machines becoming quite more powerful, and people are starting to talk about trust. What is the nature of trust? What is the nature of the relationship of all intelligent agents, artificial or human? So this, in 1985, I believe, a paper was published in the AI magazine by a neuroscientist, medical doctor, who basically said that we as scientists and helping professions, clinicians, we have a fiduciary duty to society. Basically, the public has to trust us to say that we say what we believe to be true. We are responsible to say what we believe to be correct, and we are responsible for arguing and explaining our position. And if AI is to be intelligent, if machines are to be intelligent, they also have to meet this burden of trust. And there is a quote by Carl Polanyi, a famous mathematician who lived in Canada for the most of his life, basically says, no intelligence can operate outside a fiduciary network. Intelligence has to be trustworthy, basically. So that was a good idea, and things start accelerating. Moore's law is established to say that the computers become increasingly more powerful. Every 2 years, we can squeeze double the number of transistors on a computer circuit. And Ray Kurzweil in the late 90s basically developed the notion of singularity. What he said was that the progress is even faster than what Moore's law would indicate. We are talking about the law of accelerating returns. As we make progress, the speed of the progress increases. So given what we see machines to be competent to do in the mid-90s, it stands to reason that machines will become much smarter, quite fast, and eventually they will surpass us in intelligence, whatever this may mean. And at this point, we'll reach singularity, where machines' intelligence and human intelligence will emerge, and something will happen in merging the biological bodies of humans and the silicon bodies of machines. So this is quite science fiction thing, but what we need to remember is that machines are becoming increasingly powerful. So they will exhibit the cognitive capacity of what we have been accustomed to associate with human intelligence. So what does it mean to be as intelligent as humans, and what is the implication? Jay Storrs, who is a nanoscientist and philosopher and computer science eventually, basically argues that if we indeed can make machines to be intelligent, which Ray Kurzweil says is unavoidable, we have the moral obligation to make them conscious. Because if they're not conscious, if they don't have a reflection on what they're doing, and if they don't have a value system for whether what they're doing is good, then what we would have is the more intelligent beings in the world being unconscious. And if they are conscious, it would be, they could be unpredictable, subject to their emotions. They might realize their power and sort of control us, or they might treat us with compassion. It was quite complicated of what's happened. But the argument is that if they're going to become intelligent, they have to be conscious, which includes emotion and responsibility and ethics. So we'll switch a little bit now to the second chapter, which is a little bit more technical, because now the machines are truly capable. And people are starting to talk about artificial systems, artificial intelligence, artificial agents. And there are three types of research that happens in general, and it can be broadly conceived in robotics. So AI agents, artificial agents have bodies, and they are robots, or they may be companions, or they're expert decision makers that act as proxy for a human expert. So this is the work around expert systems, as well as semantic web ideas that had us corresponding with an agent, where the agent would do all the boring stuff that we don't want to do, but they would be trusted to do the right thing on our behalf. So let's talk about these three areas. Robotics. In 2004, there was a conference that was co-organized by European Union entities and the Pontificia Accademia della Santa Croce, which basically means it's a theological school, theological and technological school in Italy. And they brought together an interdisciplinary team of roboticists with the explicit purpose of actually talking about their work and the social implications of their work. And looking at the proceedings, there were three emerging positions. Ethics is irrelevant. We're building robots, they're machines, we are technologists. The second position was a little bit mediated, basically saying robots are quite powerful and they have to have our contemporary cultural values. They have to fit in our society. And the third, more visionary group, so to speak, was interested in long-term ethical questions. But practically the majority of the community was interested in contemporary cultural values. A parallel, at the same time, approximately like 2007, there was an event that was held by the Oxford Institute, and it brought together a whole bunch of researchers who were working on a European Union project on artificial companions. And they started talking about the relationship between people, whether the relationship between humans and machines were fundamentally different or the same as the relationship between humans. They started questioning the authenticity of feeling. What can machines be made to appear to have feelings for their human counterparts? Should we make the machines mimic feelings so that the humans can believe that they have feeling? So that the questions came to in the context of robots that help seniors stay at home, and also potentially proxies that were generated for semantic web interactions. And they started talking about empathy and love between machines and humans, and whether the machines were intelligent enough to merit the term life. There are three interesting points that were made. There are many interesting points, but I want to point out three positions. The first one is similar to the boticists, basically saying we're technologists. Joanna Bryson, a sociologist, argued that robots should be slaves. We own them. And if we were to call them anything but slaves and machines, then essentially we're abdicating our responsibility of using them. So robots are machines. We are responsible. We are in control of whatever is around ethics. Sharkey and Sharkey talked about the danger of machines controlling humans. So what does it mean if a machine is babysitting a child or a senior with dementia? If the machine is programmed to protect the senior by restraining them, is that ethical? And there were some scenarios that were actually happening and at the time that basically caused this as very practical problems. And the third point was sort of, they didn't use the nothing about us without us term that we see today, but this was exactly the point of the methodology. Alan Newell said that quite beyond what machines are ending up being, intelligent or not, our responsibility is to design them with consultation with every user who will potentially interact with the machine. So there are these methodologies that basically guide technical work in order to make sure that we're not culturally insensitive. And last, I want to talk about a paper that was developed by Oren and Amitai Gioni. Oren Gioni was a machine learning expert. He studied at CMU. He is prolific, and he's actually running the Allen Institute in Washington. And I think 2017, he wrote this paper which basically said that there's no need to teach machine ethics and it cannot be done. Because if you're talking the expert system approach, then you have to build ethical principles in a machine and you have to choose ethical principles. And we're not quite sure that we have an agreed upon set of principles. Which religion should you use? Which moral philosophy? And practically it's impossible because in the end, there's no ethics framework that covers all decision making. If you take a bottom-up approach that would be advocated by machine learning, then basically what we need so many examples so that the machine can learn to differentiate between what is ethically acceptable and what is not. But it is not possible because ethical decisions are fairly rare and we don't have enough examples to generalize and learn ethics. So he argued that the point is irrelevant. Since then, he has been writing quite a bit about how to program machines in the case of war. And eventually he proposed a supervisory layer where the problems of ethics of robots or proxies or companions would be managed by some other layer of machines that would be more tailor-made to make value judgment. So that brings us to mid-2010s, and now what we have is a different methodology for AI and machine learning that relies on data very much. And this is the work that's happening today that has led us to the point of actually having very practical ethical problems about which Nidhi knows everything, and I will pass it on to her, and I will be controlling the presentation, Nidhi. So you tell me next when you want me to move.
Okay, thank you, Eleni. So what I'd like to do is move from all of this historical ideas of ethics and what a being that is a machine might need to have in terms of ethics to today and immediate impacts in our lives on ethics. Next. So it's essentially moving away from this idea of singularity to see how it impacts us today. And one particular, I mean, there are AI infused systems today in narrow contexts like warehouses and things like that. But more specifically, I'm interested in machine learning and how it impacts services that we use every day. We see effects of, positive effects of these services every day in terms of, recommendations of books or films, maps and routing in maps, personal digital assistants. I know I use mine throughout the day, every day. Health apps where we're inputting our health information and getting recommendations and other things. And also things that we don't necessarily make a move to participate in directly, such as banking and loans, judicial systems and policing, for instance. Next. And in using these services, where machine learning has been implemented, we're creating a lot of data about ourselves. And this data is really everywhere. It's in the search logs of things that we search for. It's in the purchase history of items that we buy. And this is held either by the store we've bought at, the credit card we're using, the bank that this money is coming out of. Their social network interactions, be it social media like Twitter or social networks like Facebook, even in the way that we connect to people, the people we connect to, the things we, content we put up there, there's a lot of data we're producing about ourselves. And other personal apps that we use where we're inputting our own data, like maps, health. We have doorbell cameras, there's a lot of data that we're producing about ourselves. And it provides us with great valuable services, network connections, predictive analysis. But there is also this other element where when we combine this data across all of these various domains, maybe the places that you're going through using your map app, the social network connections you have, the things that you might buy, and combining this with other people's data and what they're doing throughout the day. This is a lot of power, and has a potential to provide you with exactly personalized services, but also has a potential to have significant undesirable impacts as well. Next. So just quickly to give you an overall picture of how exactly our data is used. Now, this is really a very basic, simplistic idea, just to give an impression of how this data is used. In machine learning, essentially, a model is trained, and it's trained on data that is collected on a large number of individuals. And the higher dimensions of this data, meaning the different features or attributes in the data about you, allows you to have better insights. So when we have data from a large number of people, we use this data to train a certain model. And this model then will be used for producing predictions. Like we give it a new person's information, and it will predict, for example, a book that you might like, or a traffic route that you might take. So in looking at this overall picture, we see that data from many different people has been combined, and that has been used to learn a model about how people behave, the preferences people have, and then eventually what they may want in the future. Next. And so this brings up a lot of ethical issues in this type of AI, in the type of machine learning that is impacting our everyday lives. And in general, people talk about a few ideas relating to ethics when it comes to such services. Transparency is one, which is, how is my data used? A lot of apps that you download onto your phone are collecting data about you, but do you really know how that data is used, where it's kept, and what's done with it? We talk about explainability when we mean ethics, and that is, why am I getting this recommendation? Why is this, red shoe being recommended to me, and not, a running shoe? Why is heels being recommended to me? So there might be reasons for decisions being made about you. For instance, if you are being accepted or denied for a loan, especially if you're denied for a loan, you'd like to know why. So there's an aspect of explainability that goes along with the concept of ethics. And two others that we understand more intimately are privacy, for one, which is what is known about me and what can be inferred about me that isn't explicitly in my data, and who can infer this and what can they do with it. And the other notion is bias and fairness. Are we all getting the same treatment? If a machine learning or AI algorithm is being used to decide on my loan, or to decide on my university application, or anything else like that, is everyone being treated fairly? Are there questions of bias that we should be worried about? Next. And I'll talk specifically about two of these, bias and fairness, and privacy in particular. So one example where bias and fairness becomes important is in cases of automated decision making. These are systems, for example, of loan adjudication that use algorithms. There might be hiring companies that use algorithms. In the US, certainly there are predictive policing algorithms that are being used by certain jurisdictions. Some judicial systems are using AI algorithms to decide not only on sentencing, but also whether to grant someone bail or not, for instance. And the questions here that we'd like to know are the outcomes from these automated decision-making algorithms fair across the various subgroups? One example, a recent case study that came to light a couple of years ago is using data called Compass data, which had data on recidivism. So the risk score of individuals who are arrested, and the algorithm that would be applied on it would give you a prediction of whether this person is likely to recidivate or not. And this has been used in pretrial hearings to decide whether someone should get a sentence, should get a bail, should get jail time, or what. So this article in ProPublica came out called Machine Bias, where they showed that this technology that was used by many judicial systems in the US was actually biased, because when they looked at the did a statistical analysis of the outcomes from this algorithm, they noted that Black defendants were more likely to be given a score of higher recidivism. So they were more like, the algorithm predicted that they were more likely to recidivate when they were not, in fact. And so they got harsher sentences. And there were differences not only across race, but also across gender. So various subgroups then were treated differently and had different outcomes because of these algorithms. Now, this is, a little obviously more serious than being recommended the wrong shoe. This has implications for the rest of your life. So these are indeed important algorithms that need to be carefully curated before they can be put out in public. The question from this case study was not only about the algorithms, but was the data biased? Is the algorithm doing what it's supposed to do, which is take indicators from the data and give you a prediction on what will happen? Or is it doing something to the data that's making the outcome biased? This is a complicated question because we can actually address bias at many levels of this machine learning pipeline, this figure that I showed you earlier, where you have the data, you have the training of the data, and then you have outputs and what you can do with the outputs and how you interpret the outputs. In this case, it turns out that the data came from arrest data. So this was based on the people that the police arrested. And already there was a bias because the police were more likely to arrest Black criminals than white. And so this showed that there's an element even before you implement an algorithm that you must look carefully at, and that's the data. How is the data collected? Does it already have biases that are probably inherited from human biases because a human curated this data? Next. And this particular case study of automated decision making basically looked at risk scores, assigned risk scores to people on what their behavior in the future might be. Another area where bias was uncovered is facial recognition, where a student that she was at the time a student at MIT, Joy Bolamuini, uncovered bias in facial recognition systems, where she noted that many facial recognition systems didn't even recognize faces of people of color. In fact, there's a documentary film recently made about this called Coded Bias. We had screened it at the Department of Computing Science. And I encourage you all to go look for it and watch it. It's very interesting. Essentially, what she uncovered was that Black faces were not being recognized at all or with high error. So gender classification models, so models that look at an image of a face and try to classify the gender of that person, had higher error rates for Black women than the other subgroups. And this particular example was for gender classification, but you can imagine there are other classifications that are happening with facial recognition systems. And this can have significant impacts later on. For instance, and that's the next slide. For instance, Clearview AI is a company that uses that creates facial recognition software, and it has been used by several police agencies in North America to identify from photos or pictures of large groups people that may have been involved in a crime. And you can imagine that if a facial recognition software is already biased in the sense that it has high error rates for certain subgroups, and this is being used by police agencies to look for criminals, you can imagine that there is a lot of potential for bias in these systems. In fact, just recently, earlier this year, a man in New Jersey was accused of some crimes based on a bad facial recognition match. And he, I think, has gone on to sue the police service there. So you can imagine, a completely innocent person can be wrongfully arrested based on faulty facial recognition. So the impacts of unchecked bias in these machine learning algorithms are really very deep. The other thing I want to consider, next slide, today is the notion of privacy. Now, this is a notion that actually many of us are not even sure about, because many people have different ideas of privacy. Some people are very happy to share everything that they can on social media about themselves. And some people are very guarded about what can be learned about them. There is a non-uniform idea of what privacy is to people. But in essence, what it really means is, if there's data about me, can that data be used to infer something else about me that I don't want known? And that's really the notion of privacy that we think about in machine learning. And it really this becomes an issue because we have such large scale, high dimensional data. And that is a potential to allow inferences. For instance, if there's a data set with only 2 columns, name and age, there isn't much else you can infer about that person. But if this data has 1,000 columns with name, age, what flavor of ice cream you like, where you like to shop, what time you leave for work, with a lot of these other dimensions added to the data, a lot can be inferred about you. And some people have suggested anonymizing data sets. Let's just remove personally identifiable information such as names, and that should be sufficient. Well, it turns out that because the data is so high dimensional, the patterns in the remaining part of your data are sufficient to identify you. And this was shown a few years ago, over 10 years ago now. There was a competition by Netflix. They had this algorithm for recommending films to people, and they had a competition for researchers to improve their algorithm to be able to beat Netflix's algorithm. And so they publicly released an anonymized data set where they took away usernames and they just put in some random numbers. Well, it turns out that, and actually that this data set had only 3 values per row. Some random number for the user, the movie that they watched, and the date that they either watched it or rated it. And this was sufficient for some researchers to combine with publicly available IMDb data. IMDb, for those of you who don't know, is a website where people can leave public reviews on movies. And that was sufficient to identify people. In fact, it identified people so well that some of their preferences on Netflix were revealed, and Netflix was taken to court for it. Next. So this idea of having our data out there, even if it's anonymous, can lead to some serious privacy breaches. And many other cases have been shown where you can link publicly available census data with perhaps a small set of private data that might be released and be able to identify people. And a lot of this information is very personal and private. So this can be a serious breach. Next. So what now? Now that we know that we are hooked to all of these services that are being offered to us by machine learning, and yet there are all of these issues that we're concerned about, what can we do about it? Well, first of all, the research community has a lot of current work that's being done on these issues regarding fairness and bias. For instance, how can we make sure that data collection and data curation is not biased? How can we watch out for harmful outcomes? There are several measures of fairness that the researchers have proposed, and this really depends on the context. What context are we looking at? What type of fairness matters here? And what kind of algorithms can mitigate the bias? And sometimes the solution actually is don't build it. Like maybe if it's a predictive policing solution that is clearly has faults, maybe just don't use it. That could also be a solution. And in terms of privacy, researchers are working on making algorithms privacy preserving so that you could still get the services that you want, but information can't be inferred about you, and how we can share data in a private way. Next. And the other aspect of this is AI governance. Next. What can we do from a policy and regulation perspective? And one thing we can say is definitely that Europe has led the way in many of these policy aspects. In 2018, they came out with the General Data Protection Regulation, GDPR, which had very detailed directives on protecting user privacy and data, and it even had roles of data officers that would do the checking. It had high fines for companies that didn't abide by such data protection policies. And just recently, just a couple of days ago, actually, they came out with another one called the Artificial Intelligence Act. And the title of this proposal is called Laying Down Harmonized Rules for Artificial Intelligence. And it's something that captures the harm that can come to people from AI in terms of fairness and bias, among other things. And they have outlined very specific objectives on what safety means, what harms from AI mean, and how artificial intelligence products should be regulated to be fair and safe. So I would say overall that we sort of need a balance in innovation and research and also governance. One example I like to use is children's toys. We have regulated children's toys so that they're safe for children, but that doesn't mean we've stopped producing children's toys. We're just more careful about the impact that it has if it's been misused. I'll pass it back to Eleni for the concluding thoughts.
So it's difficult to come up with, I'm glad that Nidhi closed with governance, but I think that one point that really needs to be made is that these systems are becoming increasingly real and increasingly useful. Every research that happens in the university, within the confines of the academy, is subject to scholarly ethical protocols. And that's why governance in the real world is very important, because there is no ethical governance currently that subjects organizations who use and develop AI to similar standards. So the legal frameworks need to catch up with the work that we're doing. And at the very least, we should make sure that our systems conform with our values as a society. So Nidhi talked about representation and underrepresentation and unbalanced impact to different communities. And the laws and the policies that have to govern this conformance with values and the ethical protocols have to involve everyone. Again, I really find this nothing about us, without us, a very powerful statement on what is the right process for doing this right and deciding whether to do it or how to do it. So with that, we're looking forward to your questions.
Thank you to both of you. It's so interesting. And we have a number of comments that have come in, but I have to say with just a little bit of irony that the movie Coded Bias is on Netflix. So, and somebody did point that out in the comments. And I've also seen the movie, and I agree with Nidhi. It's interesting and really touches on many of the things that we've talked about and heard about today. So there are many questions, and I don't know that we'll get to all of them, but we'll certainly follow up on all of them. Many of the questions are about governance and who should do the governance. So I wonder if one or both of you could comment on that. So who should be responsible for the governance? And then a more directed question that I also think is really important, given what Nidhi ended with. Some children's toys have AI capabilities, and what would be the governance on those toys? So I'll leave both of those questions with you.
Nidhi, do you want to start?
Sure. In terms of governance, I think, we have actually in place regulatory bodies, and I think certainly they can take over this role of regulations. We used to have, I think we probably still do, but it's not very active, consumer protection agencies that actually had as vocation that they would look, protect consumers. And they did it for things like, toys, appliances. And, I think this should also be considered, because the argument against it is typically that it will stifle innovation. But it hasn't stifled innovations in many of these other areas, like home appliances or children's toys. So it doesn't need to stifle innovation. It really just needs to be some set of guidelines. Some people say standards, maybe. There's certain other technological devices that have to abide by standards. And if something has such a personal impact on people, then we should be thinking about, standards, and they don't necessarily need to stifle innovation.
Mm-hmm.
There's quite a bit of work on standards similar to LEED for energy efficiency of buildings. And there is a mad rush for organizations to develop these standards and get them accepted as the right standard. So IEEE is working on that. AI Global is another player. The problem with the law is that everything is international, and it's very difficult to have harmonized laws across the earth. So Europe is a little bit in a better position because they do have a shared legal framework to some degree. And that has enabled them to be faster in the race for legal frameworks for controlling technology.
Yeah. Yes. And actually, you've just touched on another set of questions, which is about how much more complicated this is for companies that might be international or in an international framework. Let me ask this question that also came in a couple of different forms. And it's about the data that goes into the pipeline that Nidhi talked about. What mechanisms are in place to ensure that the input data are correct? So what mechanisms exist, and is part of the system about checking, and a part of the systems from an algorithm standpoint, about checking the accuracy of those input data? So there's two questions in there.
I'll start by saying that it's very difficult to check that the data is correct. And that's even before understanding if the data is representative.
Mm-hmm.
It always knows in the data, the measurements are problematic, the measurement instruments are problematic. So talk about GPS. When the GPS is recorded, then it is sent to the system, but basically you are not, the recording of the GPS is already wrong at the point of the measurement. Mm-hmm. And that's basically part of the measuring and the instrumentation that creates problems. Some of the data is handwritten and understood by OCR, character recognition. There's lots of errors there. Some of the data is erroneous interception. When we fill out forms, we make mistakes. So there is a huge area of work on actually cleaning data or recognizing when it's obviously wrong so we can throw it away. And that's even before talking about, is it good enough? Is it representative? Nidhi?
Yeah, This is absolutely true. Not only is the integrity of the data questionable, but also how it was collected needs to be known. Like the example of the Compass data I talked about. There are some proposals out there. There's some researchers that have proposed an idea called data sheets for data sets, and it's based on data sheets that they have for small electronic components. In order for these components to work together, you need to know what exactly are the properties of these components. And in a similar way, they propose this for data sets, where we need to know what are the properties of this data set, how was it collected, what is its intended use, so that, you know, there may not be a way of checking for correctness or correcting, but at least there is documentation on exactly how this data is collected.
So let me ask this. If a mistake is made, so if AI makes a mistake, for example, in a medical diagnosis, or in an application, a loan application, who is responsible? Is it the user or the AI system? And can users be liable if they ignore AI recommendations? And I mean, that's a big question, but it's a really popular question. So I wonder if we can talk about that. So who's responsible for mistakes?
I'll start with the liability question of users, because it's something that's directly relevant in the SmartCondo. We are collecting information about people's activities, and then we have recommendations on what they should be doing, as in, now you wake up, now you take your pills. And there's a whole area of work on actually recommending interventions in diabetes management, in all sorts of disease management, chronic disease management. Now, if the system recommends that this is the right insulin to be consuming, does the person have to do it? We are independent in how we're managing our health, and it is our choice. And the same thing holds for all sorts of, particularly mental health drugs that have side effects. So there is no law that governs this, but this is a big ethical question. If we know that this is the right thing for your physical health and you don't do it, are you supposed to do it? Are you managing your health? Are you responsible for doing it because you are covered by Canadian health insurance? And there's no good answer, but all of these answers are at play in that area. What about the medical recommendation, Nidhi?
Yeah, I don't know about the medical recommendation, but definitely in terms of legality and AI, the legal world is catching up on AI, and I think they're working on what this means, in terms of decisions made by an AI. The only way that an AI can be held responsible is if AI has personhood, and under the law, can AI have personhood? I think this is a question that lawyers and legal scholars are asking right now. Because if it's just a traditional program, someone has programmed it to do exactly, it's sort of like a rules system. It does exactly what it's supposed to do. But with AI, it's learning patterns, and then it's making decisions or outputting predictions or suggestions based on the patterns it's learning. And so there's some element of randomness in there. So who's responsible for that randomness?
Yeah, definitely. There's way more questions here than answers. I'm actually going to end the questions with actually something that's quite simple, but people are interested in. Who approves algorithms?
As far as I know, at this point in time, there's no body that approves algorithms. And there are a few problems associated with that. We talked about certifications and standards, like the LEED standard, and it wouldn't be a requirement, but basically a seal of approval that this is a good algorithm would be a business advantage for someone. But there's also the issue of trade secret with respect to the algorithms and how you share your business advantage in the algorithm that you have built in order to get the seal. So there are some ideas about intermediary organizations that would be responsible for doing the certification without leaking. But this infrastructure is not, it's in its infancy still, I believe, as far as I know.
Good.
Yeah, I agree. There's, there are ideas floating around, but really there's no body right now that approves algorithms. I think AI and machine learning is just growing at such a fast rate that all of the other infrastructure is yet to catch up to it. So what ends up happening is, the business decision is really what approves algorithms on whether it will be implemented or not.
Well,
as citizens, we have to be responsible to ask our governments to actually do something about it. Mm-hmm. In the end, it's our society, and in some sense, we can vote for the right steps to be taken.
Yeah. Well, this has been fascinating, and I'm just noticing the time, and we're a few minutes over, but my heartfelt thanks to Dr. Stroulia and Dr. Hegde on just a really informative webinar. We didn't get to all of the questions, but we will follow up on these questions as long as the pre-submitted questions. For now, I'd like to thank all of you for being with us today. And I'm going to turn this over to Katie. And once again, a big thank you to our speakers.
Thank you, Dr. Kalkunas-Rupel, for facilitating our discussion. And thank you once again to our speakers for joining us today. We encourage you to stay connected to the University of Alberta, and there are many ways, many opportunities to get involved and stay connected to your alma mater virtually. All of our digital content is released on our social media channels first, so be sure to follow UAlberta alumni on Facebook and Instagram. And that concludes our webinar. Thank you so much for joining us and for supporting your University of Alberta.